This lesson explains how to eliminate the flicker problem in the animation of the previous lesson. Before it can be cured, you have to know what causes it. If you recall, the paint method first clears the display, then paints the next frame on the cleared window. Well, the hardware and the software are not always synchronized, and from time to time, the hardware display is updated between the clearing of the screen and the painting of the frame. Momentarily, you can see through the picture, and that makes it appear to flicker as it moves. The solution is to paint the window in such a way that it won't be refreshed with only part of the picture painted. And that's what this program does. This program is almost the same as the one that flickers, but a little bit has been added. There is a declaration right here for a reference to a buffered image object. Now you may remember that a buffered image object is like an image object, except it has some methods that make it a little easier to work with. The change in the code is in the update method. You recall that if the internal rectangle is either missing or is the wrong size, a new rectangle object is created and everything is initialized from the beginning. This is all the same except for this last line. Once the size of the window is known, a new buffered image object is created that will hold an image of exactly that size. Now this buffered image object will remain in existence until the size changes. Now here's where the buffered image object is used to prevent the flicker. If the animation is running, a graphics object is extracted from the buffered image and it's used to call the paint method. Now this graphics object is the same as the normal graphics object, except this one contains information about the buffered image instead of the actual window. That means that the paint method paints the new frame into the buffered image. So far, everything is stable. The window still holds the old frame and the buffered image object holds the new frame. Then a call is made to the draw image method of the graphics object of the window. In one operation, the entire window content is replaced by the content of the buffered image. Now this is what is known as an atomic operation. It cannot be interrupted by the hardware. So the screen cannot be refreshed while the window is only partially painted. It's either all or nothing. And that takes care of the flicker problem. And this is a skeleton that can be used for graphics for any application. Let me show you what this one looks like. There it is. The circle now moves smoothly under normal circumstances. This recording may be a little bit different. It moves from left to right on all displays. Now, this version can never flicker because the display is never given the opportunity to be painted partially. As I said, this animated graphics model can be used as a model for animation anywhere Java displays in a window. We'll be doing some more animation in a few minutes, but in the next lesson I want to show you how to use this form in an applet that runs from over the internet.